And so let me introduce Sergio Zaera Mata. He works at Iberia. And so this is a Spanish-based organization that I believe develops technology for people to use machine learning methods and so on, and like now allowing them to build it into their business and so forth. Um, he is an AI engineer, and as I mentioned earlier, he was at the Flower AI Summit a few months ago. He is a really interesting piece of work, and so we thought it would be great to have him back and to kind of give us an extended sort of deep dive into this fantastic project that's called Green, where he's using federated and collaborative sort of methods for learning with the aim towards helping us build and maintain more sustainable cities. So it's really an important application domain of this stuff. So thank you for joining us, and over to you. We're really fascinated to hear about your work.
Okay, thank you so much, Nick. Let me share the screen. Thank you so much for having me here. Today I'm going to be presenting Green. Yeah, I'm Sergio Zaera Mata. I'm an AI engineer at Iberia. And yeah, Green is it's called also Collaborative Intelligence for Sustainable Cities. Yeah, let's go. So first, I want to present a little bit of the company, just to let you know. At Iberia, it's an innovative SME. The main objective is to develop artificial intelligence software for the industry and also for the people. And now we have more than 120 professionals, where 90% of them are engineers. So we are allowing the company to have high level of innovation and interest in the new technologies. We specialize in different kind of sectors. Here you can see some, the space, also Navy, energy, here the Project Green, which is smart cities. We have different types of projects. So yeah, starting with the presentation, let me give you just the index and so you can navigate through the themes. First, the introduction, and then I'm going to explain what the solution that we're preparing, show you the digital twin that we have is the virtual representation of the city, also the models and data that we use, the results that we have, why it's important this technology combination, and that is the kind of the very important part, and finally applicability and conclusions. So yeah, starting with the introduction, Green, it's also called in Spanish Inteligencia Colaborativa para Ciudades Sostenibles. It's close to the thematic of the smart cities, and the use case of Green was to managed to get the energy demand prediction of a model for the charging station and the charging environment of the electric vehicles. The project starts with, or starts thanks to the company Red.es, which is a public corporate entity that is under the Ministry of the Transformation, Digital Transformation of Spain, and specifically to the artificial intelligence part, which is we are doing. Also, the mission of the company is to execute programs and accelerate the digitalization of Spain. In this project, we are collaborating with Naturgy. Many of you can hear about this. Naturgy is a multinational company from the energy sector and has the headquarters in Spain. And it's dedicated to the generation and distribution of and commercialization of energy and also natural gas. So yeah, we are collaborating of course, because in our company we always look to have in all the projects an expert in the domain, so we can help each other. And basically, the objective of the Green, the fundamental objective was to create a AI platform, obviously in the industrial level, and to enable the implementation of this project, but also other projects in the future exploiting this IoT data. So before continuing, I want to make a quick explanation of the charging environment, just to know the main concepts. So first we have the network provider, that is the company that transports the electrical energy and builds and maintains the transmission facilities. Also we have the charging stations, that is the infrastructure that links obviously the energy distribution with the charging of the electric vehicles. Then each charging station will have a charging station manager, that is the electricity consumer authorized for the supply of this energy. And also, finally, in the last part of the ecosystem, we have the electric vehicle users, that are the users of the electric vehicles that need this energy to run. So the use case of green is to create a prediction model for the energy demand that is required for the charging stations, and the real part is to optimize all this environment that I already present. Here you have a representation of it, where all the parts of the environment help each other just by adjusting or by predicting this energy demand. So helping one part will be helping and optimizing all the environment. Okay, so for just trying to doing an introduction, I want to explain like the functional schematic, which is the combination of the blockchain, the federated learning, and the smart contracts in this technology scheme. So first we will have the IoT devices that in our case will be the charging stations and the sensors there. That connects and use the data of these charging sessions to update the local models in each charging station. Then these local models will be added and first validated and then added to create a global model. And finally, we have all the process to update this global model to the rest of the charging station that have participated. Don't worry, I will explain this better, but just to a quick overview. So the solution. Why we need a solution, or why we start making a solution? So we identify three challenges. This challenge was not only for the energy and the mobility sector, but also are across all the industry and the sector. So first, the security. It's important to secure the relevant and the sensible information to avoid not only internal threats but also external threats. Also, reliability. The companies are sometimes not willing to collaborate with each other and to share data, because that will mean to lose these benefits of competing. But that is starting to be a problem. In the future will be really more, and we need to see what we do about that. And finally, the decentralization. The real problem is the centralization, because decentralization of the service and the process, there are really big problems, and they can obstruct, let's say, the agility to the companies to adapt to the changes. So we start to need to decentralize the systems. So yeah, for to this challenge, we wanted to solve them, and so we arrived to the project Green. Here you can see a quick view of the Green network. As I told before, we have a combination of the free technologies, federated learning, blockchain, and smart contracts, and how these technologies interconnected. So first, we have a federated learning architecture, so that allows the different users to collaborate with the local models in the creation of these global models. But we didn't want to have a central authority and a central server and to share all these local models. We wanted to be this sharing and validation process in a decentralized environment. And that's why we introduced the blockchain network. This blockchain network is offered as a service. So the people will be private, but the people that are allowed will be able to connect and to participate in this network. And obviously, this network needs to be regulated. And to be regulated, we need to establish some immutable and transparent rules that are called in the blockchain environment the smart contracts. So we are not building just a solution, we're building a transformation in the sector, mixing these technologies. Okay, so here you can see a big picture of the architecture of Green and the different models. First, we have the simulation model. That is the one that we use to create the digital twin. We implemented that with using the Sumo. It's called the simulator of urban mobility. Also, after you have the data collection model that it's uh, joined with the ML model. When we use some models of PyTorch and most of them from NVIDIA. These IoT devices, this join of the two models are connected first with the blockchain model. That is the one that has the decentralized network and allows this interaction. And the blockchain model was done using Hyperledger Fabric. And finally, we have the federated learning model, which is obviously designed by Flower, because we spent really long time deciding these kind of technologies, and Flower was the one that really like us more, best documented, and really it's really great. Um, so yeah, in the energy demand prediction, I told you before that I'm going to explain in detail how this process is done. So for the ones that didn't understand me before, here you can see more clearly. So first we have the data collection where a car goes to the charging station and charges the battery. So this data is collected from the charging station to the energy demand data, and its model, its training with its local model in its training station is training with this data. Then this model is shared with the rest of the charging station Ethernet. So the model can be evaluated by each of the charging stations. So one of the models can be approved, but the other no. So we have a voting process where the model in this blockchain network is shared. The weights of the model and also the metrics. So another charging station with kind of the same situation can evaluate if the model is good or not, let's say, for joining the net. Because if the metrics that obviously with some percentage of error is inside this rank, can be up to enter in the net, but if you detect that it's an anomaly, you cannot validate them. So only the validated local models using this net are the ones to enter for this updated of the global model. So in one phase we have the updated model that it's first sent to the ledger of the blockchain with the smart contract and with the last updated global models, and it's registered there and it's immutable. And in the other direction, this updated global model is distributed again in the net, so all the charging stations that set a local model can have the benefits. Also, this blockchain network allows us to let's say, adjust and benefit or do penalties to some of the charging station within this participation. So I'm going to start to be fast because I'm a little late. So digital twin. The digital twin. In green, the digital twin is a virtual replica that we built to simulate the physical environment of a real city. We have placed different charging stations. Well, that's actually there are brilliant charging station in a city, and you can get the energy demand of each, but you can also adjust and have clusters. These clusters can be geographical, can be separated by fast and slow charging station or others. You can see the comparison in closer detail, because you cannot see here because it's really far. But the reality is that what happening is this: we have different places at charging station with the cars are moving and are charging when they need. We have some algorithms running there, so it's be the most realistic that we can do. So what allows us to have the digital twin? So it allows us to have a real time detailed up to date information. Also helps us to evaluate and react to different scenarios, because you can adjust the scenario, the initial conditions. Also, you can simulate different strategies, let's say replacing some charging station. You can form the new people into these new scenarios, also optimize the utilization of these assets or elements, and get also a statistical from the long-term analysis. So for the results, we start with two data sets. The first one is the Barcelona, and the second one was for US Colorado. So as you can see, they are a bit different. The one in Barcelona, it's only from 1 year, while the Colorado is for a few years. But the reality is that the one of Barcelona, even though it's fewer data, it was hourly, while the Colorado has some regulations. You can see also that in Barcelona there's a difference between the blue one and the orange one, and this is because the fast charging station and the slow, that you can see better here. The fast are the ones in red that we have more data, and the ones in blue and also the green one, what is a special one, but are the slowest ones. What is important? Why is important? Differentiate between the fast and slow, because the fast ones, a fast charging station will charge around, let's say, 8 to 10 cars a day, while the slow maybe one or two. So they are in balanced state. So for the initial evaluation, you can see here the table and the first, let's say, not precise data of the dataset, and two different. The first one was the only with let's say a smoothing, and the results were really bad because it's really irregular. Let's say one Monday you can have three vehicles, but the next Monday you have eight, and there's no really a pattern to have here. So we need to have a pattern to kind of train the model, of course. So we adjust the data set to do the accumulate energy. Let's say you can see there's like a blocks. So each block it's 1 day. So we are calculated not the precision if in the hours, but the precision if in the charging energy accumulated in 1 day. This was the, let's say, the experiments with the traditional models, but the real results are here that a few of you can would see, because I presented them in the Frauel monthly, in the year summit. These are done with physics-enforced machine learning, and these models incorporate physical principles into the algorithm, so they can be better and more accurate to predict this energy time series. You can see that also the prediction is adjusted because it gets the new data that is getting from the instance zero, let's say. So these models are not only trained with the energy or historical energy or the consumption of the energy before, but also with different factors and different variables that we add, because the dynamic of the city is very variable, so it's kind of difficult to just only get good results with only the energy information. So these are a few, let's say, the size of the charging station, the geographical location, the month, the day, the climatology, the daylight price. Also, it can be important the price of the oil. So everything affects. So arriving to final, why we do this combination of technologies? Well, first, because the blockchain and smart contracts allow us to have security using this centralized structure, confidentiality, you can preserve the privacy using the cryptographic keys, immutability, because you have a permanent record that is almost impossible to alter, and encryption, you have the data securely stored using these cryptographic techniques. Here you can see the blockchain architecture that we use. I'm not going to spend some more time here, but you have two channels, one for the fast, one for the slow, an order. We have planned three companies here, and yeah, that will be big picture of all. Also, I'm not going to explain nothing new about fair learning, but you have the benefits of collaboration and having the distribution of the model training. But the only problem that we detect here, or the big problem we detect here, was having in a centralized environment. So what we have done is, with using this technology combination, the traditional structure will be centralized using a central authority and having to send all the data to the server. And with our new approach, we have a decentralized, the data and the validation process is done through the nodes of the network. So yeah, we can validate, and we can do few things that are really interesting in the area of the industry. So in the future, well, we have a few quick video of what are we doing in the interface. We have a map of the charging station, different APIs, and also the blockchain. If I'm gonna show you, yeah. Okay, so yeah, I'm gonna talk. I hope you can listen both. So yeah, here you have the map with the different charging stations. You can access to one of them, and you can have all the information here. To the right, you have the prediction of the next days, one of the next hours. Also, you can connect to different APIs. This is a sensor API. Also, this is the price of the energy, one of the Spain APIs, but you can connect to different ones. Let's say here you have the traffic information API. It's really interesting because if you are doing the geographical clusterization, it's important to know what is happening in every point, events, weather, traffic, and the sensors. So all these inputs are the ones that I explained before that are important for this prediction of the energy demand. And finally, we have the view of the blockchain that you can access for the channel policy or the information about the peer. Yeah. Okay, that was a video. And so, yeah, quick review. The applications with the combination of this technology helps with the decision making, of course, because you have more information, helps to audit better. Also, you can have a prevention of the incident, and the time reduction will be with this expertise and the all the project contributing to this urban sustainability, you finally have this time of reduction. Also, some of benefits more strategic that would be if a company make use of these platforms, so have more operational efficiency to have agility of the operation, a cost reduction because you can have some prevention. Of course, you have the effective resource allocation because you can know the available resources and where to distribute them, and also a constant availability of these thanks to the information. So green was not only a solution, it's a transformation that is using these three technologies, blockchain, fair learning, and smart contracts. This combination strengthens not only the operational efficiency, but also helps with the decision making. And we have also starting to do some other use cases. The big one that I will show you later, it's well now actually, it's the one that about not only trying to predict the energy of the charging station, but also the big picture of the city. So the prediction of the energy consumption in a city. Also, we have some projects starting with using these technologies for the logistics sector, the medical, and also for the mobility. In this case, is the ships and the vessels. So just to show you that this is not an invention, these are the results that we are having from the city energy prediction. As you can see, this one is about 24 hours. So we are predicting using only the 24 hours before and predicting the next 24 hours. But we, as you can see in the back part of the graph, we have done with a really big index of the window. The ones that is in the corner, this right corner, the bottom, is I think from 1 week. So yeah, we are getting really big nice results here. And just to show you that it's not an invention, we are using these technologies for other use cases, so it's very important. And to conclude, three key reflections. This project green and the collaboration of these technologies allows the collaboration, the mutability, and the privacy, and this is very important for the future development of the industry. So yeah, thank you so much. Thank you, Nick, for having me here. We are hope that maybe next year we are going to present in the Flowers Summit other project with this technology and more accurate to the further learning. You can send any questions. Well, we can ask now, but you can send any questions to our mails and access to the webpage. And also thank you to the team of the Green team that helps to develop this project and have spent a really long time doing this.
Great, thank you so much. It's a pretty impressive system. Not only does it use a lot of machine learning and things, but it's obviously quite a fully fleshed out system, being able to do all these predictions and connecting it with these energy charging sites and so on. Yeah, it's very cool. Well, if anyone wants to ask questions now, feel free to do so. I'll take a little look to see what we have, and particularly in the Slack, while people are thinking. But 1 second, let me see what I can find. Yeah, one question here is about just the question of blockchain, and if that component slows down the learning much, or does it kind of introduce new overheads that don't typically get seen? If so, how much?
So okay, let's see if I can come back. Let me check, and I can show you also the better with the scale. Let's say maybe here. So yeah, we are not slowing down the process because if maybe here, well, we are just adding this decentralized structure in which we validate the models only. So the process will be kind of similar in terms of time, just a layer with the blockchain that has more benefits than other, because you have the let's say the authorized access with the cryptographic keys and also the security, and really important thing, the validation of the models, because you don't need to think as a one big blockchain network. It's more like I told before, but different channels where there are clusters where these charging stations work similar, so they can validate because the data that they manage, it's kind of similar in terms of geographical or in terms of fast and low. It's different. And also we are planning to start these adaptive clusters in which if we detect an anomaly, we can readjust the cluster in another channel of the blockchain.
I see. Okay, makes sense. Okay, yeah. Cool. Another question, because it's just confirming that the results you were showing were driven by a mobility simulation, and they're asking if you also can use traces of actual observed mobility, like watching people, I guess, drive around in cars.
Okay, so yeah, we the results I have shown, they are not from the simulation. We have done the simulation in terms because we wanted to create synthetic data. We are up to the conclusion that we already knew that it was kind of difficult, but it's possible to create synthetic data. In the beginning, we wanted to use only the synthetic data, but finally we arrived to these two data sets. As I told, there are kind of have difference, but the results are the combination of the data in the synthetic data of the simulation and the data of the datasets, specifically the dataset of Barcelona, because the simulation was also done using the Barcelona city. So yeah, these results that I have to do so fast, but yeah, the result was done using the both, but mainly the Barcelona data set.
Oh, I see. Got you. I see. Got it.
Yeah.
Yeah, there's another question here. Let me just, it says, was the green deployment fully distributed via blockchain, or does it also have a server client model? And
Well,
what is the current and future scale of the number of edge clients? I guess it's a two-part question.
the second part, can you repeat, please?
What is the current and future scale of the number of edge clients?
Okay, so maybe I didn't explain that, but Green is a project in the TRL 4 to 6, so it's kind of a innovative project. So yeah, the sorry, I forgot the first one. Let's answer the second one.
Yeah, the first question is the green deployment, is it fully distributed via blockchain, or does the green deployment have a client server model as it runs?
Okay, so it's mix. Let's say here, maybe in the architecture, we are mixing. Let's say because you have different levels of mixing further learning and blockchain. We are doing, as I told you before, we are finishing the project. So we are doing the last experiments in this because the models is closed. We are having really good parameters in the models, but we are doing some experiments trying to figure how mix we are going to have this interaction between federal learning and the blockchain network. So the architecture here is that the model is sent to the network to each node. We are working in, we have some options. First, having just not an authority, but some node that have a part of the prediction, of a part of the database or a similar, and can check this, can validate this model. And the other is that the ones that we are actually deploying, it's you send the model to different as it was in the network policy, you in the blockchain policy, you set the model to the different nodes. The different nodes have to vote and validate through this algorithm, and then when you validate it, it's done. So it's we are working in these two parts. So yeah, we are still doing some innovation here, but the main objective is that in this month we close with this validation through this node. So I think will be fully mixed with all the blockchain. And the other one was that I stopped before. Green, it's not small, but between four and six TRL project. So it's an innovation project. So we have some things that still needs to manage that we are actually implementing more in the last the project that I sent. That is a big picture of the energy demand of a city, clustering by houses or clustering by streets or parts of the city. And in this project, we want to also add the ones that I told you, this adaptive cluster, but also some mechanism of differential privacy aggregation that I didn't mention here because the level of the project.
Cool, cool. We have one more question here, and that was it's a question that refers to some of the earlier slides you showed at the start, and they want to know what is the use case for space that you've been working on? I guess
Okay.
slide earlier that shows some space. Yeah, I guess this one here. Yeah.
Yeah. Okay. So Zaera, it's a satellite data AI. It's a project that we are developing. It's started with Consciente. It's a program in Spain in 2018. We're actually developing the second phase of this project. You can, I think it's linked to the QR code, so you can check it. we are developing the second phase, and it's a project for the Cobam, and it's like the army of the Spanish army, and it helps to the defense analyst with the image satellite with the image analysis of this vessel's information. So I don't know if you can see down here, but you have different tiles in a map, and you can have the information of well, we have a plenty variety of use cases like detection of vessels. Also, not only for the maritime environment, but also we're working with the land army. So yeah, we're working to detection of changes in the coast, changes in the terrain, new houses, new ports, detection of artillery. So yeah, we are working in different sectors. This is only a few of them, but yeah, if you check the web page of Iberia, you can see all the projects that we are developing.
Great. Yeah, very good. Cool. Well, then that's all the time we have for this talk. So thank you very so much. This talk has been great. It was really interesting.